Okay, the sample's just been mounted. The first thing that will happen is we'll rotate through 360 degrees. So we'll be taking 8 images, 40 degrees apart, and we'll feed those images into XREC. And if XREC can center the loop based on those images, then it will do that. If there's not enough information and we need to zoom out, the camera will automatically zoom out digitally and XREC will be run again. In this case, XREC did indeed find the loop. There was enough information from those 8 images. So then our software will do an automatic second centering with XREC in order to get a nicely reproducible loop centering. And that's what you see there. All right, so now you see a green box and the red box inside. The green box is the size of the grid that we're going to scan. And so we've centered the loop, and now we're going to look for the crystal with X-rays. And in this case, we have a 7x5 grid of 30 micron steps. And we're using a Pilatus 6M detector, and so we're able to actually basically do a fly scan through each row. So we'll do our 5 rows of 7 across. And then what we'll do is we'll take those 35 images, and that's what's happening right now, is actually the images collected from the Pilatus go onto a RAM disk, and then they are synced over to a Linux box. And when we get those 35 images, we'll run them through software that will do spot counts and find out where on the grid we had the best diffraction. So we've done that, and now we've aligned to the best spot on that two-dimensional grid. And we're going to now rotate. What's happening now is we have a single-dimensional grid scan done across the thin dimension. I mean, right now it looks like we're doing it across the flat face of the loop, but the camera is 90 degrees off from the beam. So that was a single-dimensional scan of the thin dimension of the loop, and that's being analyzed as well and going to the hot spot in that dimension. Okay, so now, so the loop's been centered. We have found the point of best diffraction using the 2 grid scans. Some of the flipping back and forth that you see there is so that we can collect images to put in our experiment tracking database. We have automatic logging, and so that's what you're seeing there. Okay, so now that it's aligned, we're going to take 2 images 90 degrees apart and run them through a resolution finder. And those results are then used to determine whether to collect data or not. And this will happen automatically. And that's been completed, and now the automator comes in, pulls off the sample.